ladies and gentlemen. Welcome to the International Conference and Members Meet organized by SAARD in association with IRAJ, ARSSS, WRF, ACN, SARC, Science Globe, and WAFR. On the behalf of Inter Organizing Committee, I, Dr. Kumar, Organizing Secretary, would like to welcome you all for this virtual conference. SAARD is the world's largest non-profit organization, organizing meant to organize the research and organization meant for research and development and promotion in the field of science, engineering, technology, management, economics, and social science and medical health sciences. So it's a permanent body which has brought technical revolution in the field of this. And talking about the organization has been conducting conferences from a decade-old organization, conducting conferences from many years. So about the organization, it's been publishing having more than 10 international reputed peer-reviewed journals. Along with that, we have more than 700 plus physical conferences which has been conducted till date, and more than 500, 600 virtual conferences from pandemic, post-pandemic, from pandemic time. We have started conducting a virtual mode of conferences from pandemic time. Before that, it was virtual physical conferences. So put together, more than 1,000 conferences has been conducted by the organization, and more than 1 lakh of people have been associated in the journey of these conferences, and more than 50,000 papers has been published in our journals. So these are some of the facts and figures for your kind references. So this is about the organization, and I welcome you all on behalf of my organization, and I'm Dr. Kumar. I represent Acharya Institute from Bangalore, and I am a professor from Mechanical Engineering Department, and I am organizing secretary for the day. So this is about the brief about the session. We'll quickly go ahead and start the session for the day. I now call upon the first presenter to go ahead and present. So before that, I would request participant to turn on your video for a quick group photo.
Professor's paper. The title is Forbes 500 Best Startup Modern Startup Growth Strategy by Legitimacy. The paper focuses on the legitimacy theory. This content divided are 5 parts. And the introduction. The main objective of this research is trying to adopt classical case of putting an older theory, legitimacy theory, to test of modern times 2022 Forbes startup data represented by contemporary startup funding IT-based technology, high startup cost, and highly competitive. So the literature review is the mainly literature is Zimmers and Zent 2002 suggests that 4 types of legitimacy strategy, and they find that the legitimacy include a 4th strategy about the creation a startup originate a creative legitimacy strategy. So the study framework suggests that 4 hypotheses include the conformance legitimization and the selection legitimization and manipulation legitimization and creative legitimization. Also, this creative is the research's point, and the direct impact on new venture capitalization. The utilize financing outcome to measurement. The research hypothesis and one about the total borrowing and the debt growth and the growth speed, and the 2 is total borrowing and the debt growth and the growth speed. This part I don't want to more detail. You can, if you're interested, you can see the proceedings. And the source use the SPSS, and the sample total of the 3 more than 300 firms consistent complementary startup in the Forbes sample, and the data from Forbes 500 startup website. They divided complementary startup and normal startups. Here is the result and hypothesis. And the result conclusion have three. First, contemporary startup that specialize in IT-based innovations are able to exploit the commercialization of R&D as a business model. The second, Forbes 500 startup are visionary complementary startup. And the third hypothesis, the complementary startup price manipulation and creation, especially high-level legitimacy over that conformance and selection lower level legitimacy are supported. Is she the papers? Also, I was at the airport waiting for a transfer, so can I directly introduce my study?
Yeah, please go ahead. Please go ahead.
Okay, thank you. This research is I and the Professor Jing. Professor Jing, we utilize the underdog effect the theory to investigate marketing and psychology problem. It's about the perspective of brand biographies analysis, advertising competitive strategy. Our proposal is in China, a lot of vintage brands rebuilding fashion trends in the Z generation. So we find this phenomenon. We want to know why the well-known brand or lesser known brand, they want to choose the lesser known. Especially this picture, the A is Nike, and the B is the Chinese brand favorite. In the most popular of world is a less known brand, but the Chinese new generation want to favorite rather than the Nike. So we aim to investigate the competitive advantage of strong brands while the weaker brands utilize emotional marketing strategy. And we want to know the underdog effect on weaker brands. The first, how the underdog brand biography of weak brands affect consumer willingness. So we infer that consumer have a higher intention to purchase from weak brand than adopt the underdog brand biographies. So we infer maybe two key points, and is emotional orientation and perceived justice. So we utilize the psychology experiment to test this thing. So the phenomenon of underdog and empathy. The underdog effect reveals that the phenomena, while customers are more inclined to support individual or entirely that face forbidden and competitor on the path to business. So we want to see the theory of the underdog biography, how to use. So the brand biography, this Matila suggests that brand biographies predominated aim to resonate with consumer emotional to garner their supported. And this is our research gap. Sorry, my because I in the airport, so I have the phone number. This we inference. We suggest that perceive justice as a mediator role, and the empathy as a moderator role. This is our framework. And the hypotheses also three hypotheses. The one is strong brand utilize the bolster for brand biographs and the underdog brands adopt modest brand biographies. It will lead to an increased purchase intention among the consumer towards the underdog brand. And the two is the perceived justice have a positively immediately. And the three, the hypothesis the three is the moderator effect. So these are experimental design, and we utilize the SPSS process to test this mode. This our finding and the result. These are moderating result. This is our result and finding. We can see this study explore the effect of underdog advertising position strategy for weak brands in the context of the advantage and investigate the moderating role of competitive intensity on the underdog effect. So we find that in highly competitive advertising environment, weaker brands have a greater need to adopt the underdog advertising position strategy. So that's what that's all.
So, hello everyone. I'm Balaguru and I'm a student, and we are currently researching on an SQL visualization model along with the natural language to SQL query conversion. And so, let us dive into the introduction now. As for the introduction, we know that SQL is a very popular language for database management, and it's been used for around many years now. And majority of the database use SQL for the data manipulation and data definition. One of the major things that we saw is that with the growth of natural language, the query generation can be made easier. This is because it takes quite some time to train people and also make them get a good expertise in SQL. So in order to simplify the process and also reduce the time and cost that is associated with this, we proposed an SQL visualizer and also a natural language to query conversion. So the problem statement is the lack of a visualization tool for SQL and also the relationship mapping among tables. Relationship mapping means when there are multiple tables, tables are connected using relationships. But one major drawback is that there is a lack of visualization tool where it does not state the type of relation that takes place between two tables. So in order to overcome this and also generate queries based on natural language to SQL, we have proposed a visualization tool and also the conversion of natural language to SQL queries. So this is the literature survey that we undertook, that we took. The first one is Querylizer that proposes a platform where SQL tables can be visualized. But one major thing here is the lack of relationship mapping among tables. And also there is a conversion of natural language to SQL queries, but it is not a schema aware process. The second one is natural language to ER diagram conversion. In this approach, the major thing that we got to know is that the selection of keywords for the generation of ER diagrams, which was very useful because we had to do our thing also to generate tables. So it was very useful to identify keywords. The third one is natural language database querying. This model proposes a separate language engine that can be used to produce SQL queries. It produces multiple SQL queries so that the user can choose which one is better. And also there is a thing called query rejection, which means that sometimes the query is unable to generate queries, then the query is directly rejected in that case. As for the next one, this is the natural language to web interface information retrieval. This is directly this provides a direct approach to a schema-aware natural language generation, meaning that the schema of a table is available to the machine learning model prior to its generation. This provides a higher accuracy level for this. And the next one is BERT-based text to SQL. This is the recent advancement in SQL query generation. and it uses a classification model that uses all the schema, and it separates out the classification and provides a higher accuracy. And a review of NLIDB shows that the available datasets are Spider dataset and WikiSQL dataset. These are the two major open source datasets available for training. And also the type of research that's going on, and also the outcome of these results. The research concludes saying that the some clauses are unable to provide higher accuracy when generated through a natural language. And the framework that we are using, we are building a web application based on this. We are building a front end with Next.js, and it is a visualization tool that provides a drag and drop model for the user. And we are using two servers for the normal database storing for the user data. And the next one is for the machine learning or natural language model. And the system architecture, as I said, the front end is composed of the React JS, Next.js, Tailwind, and all. And the backend is we use Postgres SQL for the database storing, and also the NLP model is deployed on AWS. This is the architecture diagram that we have come up with. The user uses one interface where they are able to visualize, generate tables, and also generate code based on the given schema or they have generated. And the server consists of two types, as we saw earlier. And the workflow, the user can sign up through the website, and they'll be able to get to a dashboard where they'll be given all the options that are available, like create tables based on a drag and drop module, and generate a query based on a text, and also create tables from existing SQL schema available. Apart from this, the type mapping that we do is each node of the drag and drop model represents a table. In these tables, we can add all the schema that is available for a model. And apart from that, when two nodes are joined, it means that there is a relationship, and the type of relationship is also shown with the edge, and the foreign keys are generated based on it. And the system module consists of two modules, which is the visualization tool and the natural language tool. The visualization tool, as I said earlier, consists of nodes that are connected through edges. The edges represent the relationship among the tables, and also the type of relation that exists. In one case, that is, there are actually four types of relations: one to n, n to one, and n to n. In case of an end-to-end mapping, the SQL table requires an intermediate table, and we generate these intermediate table within the edge. And as for the natural language module, the natural language module is built on SQL Coder 34B, that is based on Code LLM model, which is a 34 billion parameter model, and it's fine-tuned. And we chose this model because it provides higher accuracy, and it also supports schema-aware generation, meaning that we send the schema to these model prior to the query generation. Thus, it provides a very high rate of accuracy. And this is the comparison of SQL Coder with other large language models. In order to, we can see that most of the query generated have a very high rate of accuracy compared to the recent models that are available. And now we come to the results. The results is we were able to create a visualization tool that allows user to create tables, visualize tables, and also understand the database mapping, the relationship mapping among tables. And as for the query generation, since we are passing on the schema along with the query generation, the result that we got was pretty accurate and was very good when compared to other results. And this is the screenshots of our proposed application. We can see that in here we see there are two tables and also the type of relation. This is the type of end-to-end mapping that creates an intermediate table in the edge. And these are the create queries that are generated when the tables are created. And once we are done with it, we can generate a SQL query from natural language. We give the user an input field where they can give the input. And once they click on generate, the query is generated, and the user can use the query wherever they want. That's it. And as for the conclusion, we were pretty good in creating the visualization tool. And also with such UIs, it becomes very much easier to manage complex database systems, and also people no need to spend much time learning SQL and being an expert in that. And the further improvements that it can be done here is to include other database as well. Currently, we are doing it for PostgreSQL, but we can later include to build queries on multiple database systems and also different types of data manipulation languages. Thank you.
My name is Jagdish Patil, and my team member name is Ashwini Sonje, and we both have research on a tool path planning for hole making operation using real coded genetic algorithm. So this is our agenda: introduction, real coded genetic algorithm, challenges, problem statement, steps, results, and finally the conclusion. So moving towards the introduction. So as we know nowadays, various industries are having different drilling techniques, but most of the industries use CNC machines, which is a computer numerical control actually, and it's programmable and efficient to use, but it has a certain disadvantages like cost, complex programming, tool changing, time is high, and chips generated by machining is also high. And moreover, also high-speed drilling leads to the wear to the tools. So for hole making operations of different diameters, algorithm called RCGA, nothing but a real coded genetic algorithm is being employed. So as RCGA has certain advantages, so like ability to handle the continuous variable spaces. Okay. And explore the search space efficiently and adapt to changing conditions makes it powerful tool for optimizing drilling operation. So you must be like, why we have used RCG? Because manual trial and error approach or the heuristic algorithms are used to obtain the solution of such problems. And however, these methods don't generate the best solution. So we have used RCGA because it's meta heuristic and it is a discrete method. So now basically what is actually RCGA? So RCGA is a type of algorithm, optimization algorithm inspired by the process of natural selection. It's used to find the best solution to a problem by mimicking genetic process, real coded. Means it deals with the real value parameters instead of binary ones. Okay, so making it suitable for problems with continuous variables, like optimizing numerical value in a range. So further, Ashwini will take over. Uh, sorry, we actually research one. We have challenges for it, and our two we have actually two motives for it, and our challenges is lies to minimize the total distance travel, and also to minimize the switching time for tool. Now, Ashwini,
I guess Jagdish, we're not able to hear Ashwini's voice. Please check check the technicalities, or you can continue.
Hello?
Yeah, we can hear you. You can continue the presentation.
Okay. Go on.
Can you continue behalf of her for your teammate?
Bhagna, check.
Hello.
Yeah, we can hear you now.
Sir, it seems like we have a network problem. So sorry for
Okay.
that.
Yeah, please.
Continue. Continue. So thank you.
So good afternoon, and I'm all present here. Let me introduce myself. I am Titu Babu, a research scholar, TKM College of Engineering, Kollam. The topic of my presentation is comparison of period doubling bifurcation to chaos of Rosler model using complex network over maximum Lyapunov exponent. The content of my presentation are objectives, introduction, methods, result and discussion, conclusion, and reference. Objectives: development of graph-based novel approach for analyzing Rosler model, construction of complex network from Rosler model, the relation of graph features to bifurcation analysis of Rosler model. Why bifurcation analysis based on complex network? Bifurcation is a changes in topological or qualitative structure. Bifurcation analysis is crucial in understanding dynamic systems, revealing how system behavior changes with the parameter variations. It helps to identify different possible states. How network topology or structural changes influences the system dynamics. Introduction. Complex network analysis is a field of study that focuses on analyzing and understanding complex systems represented as networks. A network in this context refers to a collection of nodes or vertices connected by edges or links. Complex network analysis aims to uncover the structural properties, patterns, and dynamics of these networks to gain insights into their behavior and functioning. In our study, I took a Rosler model, which is a chaotic model, which exhibits a period doubling route to chaos. So these are the three equations. X dot is equal to minus y minus z, y dot is equal to x plus a, and z dot is equal to b plus x minus a into z. Here, where a, b, and c are all parameters, and this model contains only one nonlinear term. By keeping a and b fixed and giving different values to one of the parameters c of Rosler model, varying from 1.7 to 5, we have analyzed period doubling bifurcation to chaos. In this model, we fixed the parameters a at 0.41 and b at 0.8. Here we can see different states are there: period 1, period 2, period 4, and chaotic stage. So in these cases, the range of C varies from 1.7 to 2.1, 2.2 to 2.5, 2.6 to 2.8, and 2.9 to 5.0. Now, Lyapunov exponent. It is used to calculate the chaos in a dynamical system. The largest Lyapunov exponent measures the average exponential rate of divergence or convergence of nearby network states. Methods. Time series can be modeled using complex networks to unravel the hidden information by investigating the interactions of a number of network parameters like average path length, between a centrality, degree centrality, eigenvector centrality, graph density, and transitivity. The characteristics of a time series signal can be evaluated through a complex network-based approach utilizing various mapping algorithms like correlation matrix, recurrence plot, visibility graph, and others. A simpler method to construct a complex network from a time series is that based on the correlation mapping approach. We partition the time series into segments and consider each segment as a node of a graph. Two nodes are connected if the correlation coefficient between the corresponding segment is greater than a prefixed threshold value. The Pearson correlation coefficient between two random variables x and y is given by PCC is equal to sigma xi minus x bar into yi minus y bar, the whole divided by root of sigma xi minus x bar the whole square into sigma yi minus y bar the whole square, where xi is the value of the x variable, x bar is the mean of the values of the x variable, yi the values of the y variable, and y bar is the mean of the values of the y variable. When PCC is 1, 0, or minus 1, the nodes are considered perfectly correlated, uncorrelated, and anti-correlated. Construction. Create Rosler time series by parameter C range between 1.7 to 5. The time series is segmented into nodes with 20 data points. The edge is said to be formed if the Pearson correlation coefficient between the nodes is greater than or equal to 0.8. We define an adjacency matrix Aij is equal to 1 if the PCC value is greater than or equal to 0.8 and 0 if the PCC value is less than 0.8. So based on this, we construction of complex network from Aij. Calculation of network parameters, average path length, between a centrality, degree centrality, eigenvector centrality, graph density, and transitivity. And we calculate the maximum Lyapunov exponent of the time series and compare the MLE with the network parameters. The result and discussion. This graph shows the time series of period 1, period 2, period 3, and the chaotic stage. In the first graph, it is clear that there is only a single layer, it means that is period 1. And in second graph, right top, you can see that each block is repeated after twice. That is why it's called period 2. And in the third graph, left bottom, it's period 4, and the right part is which is a chaotic form. So based on this time series, at different stages of the complex network is given here. We use our software to form this complex network. So period 1, period 2, period 3, and chaotic stages are there. Here we can see in the next 3 slides, slide number 13, 14, and 15, you can see the multiple bar diagram. Here, in general, Lyapunov exponent is used to measure the chaotic behavior of a dynamical system. In our study, we show that instead of using this Lyapunov exponent, the parameters of complex network can be used to measure the chaotic behavior of a dynamical system. So in the first graph, it is average length. It can also advantage to think of path like a series links connecting those nodes. In the first graph, that means x-axis we are taken the period 1, period 2, period 4, and chaos. In all the cases, we are taken the different stages along the x-axis, and in the y-axis, the parameter values are taken along the y-axis. In the first graph, you can see the average path length. In period 1, initially informed, it ranges from 1.7 to 2.1. From that range, we took one value and find the average path length as well as the maximum Lyapunov exponent that is plotted in period 1. And period 2 ranges from 2.2 to 2.5. And from that range, we again select one value and find the average path length and the MLE, and it is plotted in second plot. And in period 4, which ranges from 2.6 to 2.8, the same procedure has been done. We took one value and plotted the average path length and the MLE. And the last stage, which is a chaotic stage, that is the value ranges from 2.8 to 5. We took one value and find out the average path length of that value and the MLE, and it's plotted in the graph. In that graph, you can see that as the average path length increases, the MLE value is decreasing. The same procedure we did for the another parameters like between centrality, which is the between centrality of a node is the number of times that it acts as a bridge between two other nodes along the shortest path. The same procedure we did for the between centrality as well as degree centrality. That's another parameter, eigenvector centrality, graph density, and transitivity. The same procedure we did, we took each point from each period, that means period 1, period 2, period 4, and chaotic stage, and we plotted the graph and we come to the conclusion. The conclusion is, thus it is evident that each behavior for period doubling root chaos of Rosler model is reflected in the complex network. In order to achieve a greater level of understanding regarding the period doubling root chaos of Rosler model, numerous graph elements such as average path length, between centrality, degree centrality, eigenvector centrality, graph density, and transitivity are estimated and analyzed. This is a study. So finally, instead of using this Lyapunov exponent, we come to the conclusion that by using the parameters of complex networks, we can measure the chaotic property of a dynamical system. These are the references. Thank you.